other things. So if you're seeing my screen, you should see the very first question, snip in, question 3.
Mm-hmm.
Okay. With these problems, no picture is given, and that is a kind of a key skill here is can you draw the picture? So it says here an 8-foot long piece of 2x4 wood is used to prop up a fence. If the 2x4 makes a 35-degree angle with the ground, how high above the ground is the point where the 2x4 contacts the fence? So these are all going to be right triangle problems,
Okay.
and you should draw a right triangle. So depending on like what you visualize, this piece of wood is leaning up against a fence. So the fence is over here. This is the ground, and this is the 2x4. What is the length of the 2x4?
8 feet.
8 feet. Yeah, and actually has nothing to do with this, although those seem to multiply there. It makes a 35-degree angle at the ground. That's this one right here. So when you're drawing a triangle and you have the angle with respect to the ground, this is called the angle of elevation. This is actually covered in the question 1. So that's the angle of elevation, and then if we needed to, this is called the angle of depression. Notice it's not pointing to the angle inside the triangle. It's pointing to this other angle.
Mm-hmm.
Sort of if you were looking down, I guess. These two angles are congruent because these two lines are parallel, and parallel lines cut by a transversal, you get this nice congruency.
Oh.
Doesn't have anything to do with this question, but it's just something that could be asked. So if we just redraw this triangle without all this information that's sort of extra, we have 8, 35, and we're trying to find the height of the fence. So we have 3 trig functions that you're supposed to know about: sine, cosine, and tangent. So I draw it this way. The O and H means the O stands for opposite,
Right.
the A stands for adjacent, and the H is for hypotenuse. So relative to this angle, what is H and what is 8? And these are your 3 options here.
H. Wait, in terms of like the fence and ground picture.
Yeah, actually, maybe I shouldn't use this letter. Let me use a Y here instead.
So Y would be the opposite.
That's right.
8 would be the hypotenuse. And
So which of these 3 trig functions uses the opposite and the hypotenuse?
sine.
Sine. So the sine of 35 degrees equals the opposite over the hypotenuse. Is it clear how I came up with that? Okay. So now you have to solve for y. So you do that by multiplying both sides by 8.
Well, it says you don't even have to solve, but maybe she would ask you to solve.
Yeah. Well, this one actually, I think, doesn't it ask for? Yeah, it says how high above the ground is what it's asking for.
Oh.
So y equals 8 times sine of 35. This is where you definitely need to have your calculator mode. Mode needs to be in degrees.
Is there anything in this unit that it would need to be in radians for?
Possibly some graphing, if you're allowed to use your calculator for graphing.
Let me find the answer. It's 8 sine 35. It's in degree. Okay, 4.59-ish. That's what I got.
Let me try this as well. 8 times sine. Yeah, 4.59. Okay, now let's say we wanted the other leg. So we know that this is 8, this is 35 degrees. We called this y. Let's call this x. Which of those trig functions would you use to find the value of x?
Is it 4.59 degrees?
No, it's a height, so it's whatever. I guess it's in feet because of the Okay. because of the 2x4s
Right.
and feet. Okay, so which of these trig functions would you use for
For this one,
for finding x? Let's say you want to find x.
Either sine or cosine, probably. Oh well, you should do sine because you know the opposite and you know the height.
But we're trying to find x this time. X is adjacent, 8 is the hypotenuse.
Oh, so cosine.
Yes, so the cosine of 35 degrees equals adjacent, which is x, over 8. So if to solve for x here, you'd multiply both sides by 8. So x equals 8 cosine 35.
And it doesn't ask you to find that piece, right? It just
No, but I mean, you could just as well be asked for this,
right.
one or
Okay.
the other. Do you generally get questions that are the same as your practice?
Oh no, no. She's very eclectic with her
Okay.
with her test.
Okay, so probably a good thing that we're doing it this way. All right, so when you get that, we can move on to, that's feet. We can move on to question 4.
Okay.
Okay, this one says got an airplane flying around. Okay, so we got an airplane flying out of Kennedy Airport at a speed of 450 miles per hour and a course of 320 degrees. So what's interesting is sometimes in these airplane slash boat problems, sea problems, they actually use north as their zero.
Okay.
I don't know what your instructor uses. Sometimes they use the unit circle where this is 0 degrees and you go that way. You have any idea what your instructor uses for this?
I I would think that she uses the second one. Wait,
Okay.
we haven't done a problem like this in class,
Okay.
so maybe the zero. I don't know.
Okay. Well,
Does it
I'll
matter?
just
Does it make a difference?
no. I just want to be consistent with whatever you're doing. So let's just go with the second option, and we'll talk about with this with respect to unit circle. So straight up would then be 90 degrees. That's 180 degrees, and then 270 degrees. That's if we continue around, and then this gets you to 360 degrees. So this course of 320 degrees means it's, I don't know, it's heading like that. You follow that? Like
Yeah.
it's starting there and it's going this way. Now how far is it? I'm sorry. How far does it go? Well, it's a distance equals rate times time problem. Your distance is your rate, 450 miles per hour. Your time though is in minutes, but this is in hours, miles per hour. So you have to convert that minutes to hours.
Oh, okay.
So 30 minutes is, you could think of it as there are 60 minutes in 1 hour. So the distance is 450 times 0.5. So you go this way, 225. Is that okay?
Yeah.
Okay. So then it says, and this is where it's a little awkward. It says then it changes course to 230 degrees. So if we imagine for a moment it just completely stopped. That's 90 degrees. That's 180. That's 270. It's going now this way because that's 230. It's somewhere past 180, but not quite there. And it goes that way. Do you agree with that?
Yeah.
Okay. So this is 90 degrees because 320 minus 230 equals 90 degrees. And I wrote this earlier because this is the part of the class you're in. All of your problems that you're dealing with are right triangle problems.
Uh-huh.
So if you get something on an exam, you really should somehow there needs to be a right triangle created as a result of that. So now it goes this way. Well, how far does it go? Well, it says it flies for another hour. So this time its distance is its rate, 450. The time though is 1 hour instead of half an hour. So it goes 450 miles. It goes, I don't know, it goes something like that, we'll say.
Uh-huh.
Okay. So it goes this way and it goes this way. And then they want to know its distance from the Kennedy Airport. So here's the airport up here. Okay. So how do we find the hypotenuse of a right triangle? Because that's what we have here, C, if you will.
Pythagorean Theorem.
Yep, a squared plus b squared equals c squared. And a squared is 225. B squared is 450 squared equals c squared. So you're going to add those two numbers together, and you're going to take the square root of that to get your value for c.
Squared. Okay, so that's square root of 225 squared. Seems like quite a big number. 503. Okay.
Yeah. Okay, so that's how far it's traveled. It started here, and this is 503. Great. Okay, now this is the harder part. Is we now need to figure out its angle.
Okay.
Okay. Now, there's a lot of ways to do this. I don't even know the right way to suggest. The angle we really want is this right here,
Mhm.
which means we need to know the angle that's made with the x-axis in this. Problem is it doesn't really make a nice angle there. So, what do I even suggest here? We know, what do we know here? So if you calculate, and I don't even know if this is the best way to do it, if you calculate this angle right here, it's the same as this angle up here. Do you follow that? Because the lines are parallel.
Oh, yeah.
So,
Okay.
so we can get that angle, that's the same as that angle. Well, the angle we want, this one right here, is 90 degrees plus another 90 degrees plus whatever this is, which happens to be 45, because of the way this is cut, plus this angle we just found. If you don't like that, there's other ways you can do it. I don't know how you did this in class, but that would be it. So, what maybe, and that's where this problem. Maybe we should stop on this problem and move to another one so that we don't dilute what we did here, because it's getting to another degree of difficulty.
So
But
is the plane's bearing and distance from Kennedy Airport, is that 503?
just the distance is 503.
Okay, that's the distance. So what is the I don't what is a plane's bearing? I don't even know.
That's what we're trying to figure out. That's the angle.
Oh, angle. Okay.
Yeah, that's the course, I believe. And that's where, again, it gets kind of weird. So let's just find this angle down here. This is called, we'll call this angle A. So relative to angle A, what is 225 and what is 450? What names would you give those?
What is
And these are your options: adjacent, hypotenuse, opposite.
relative to angle A?
Yes.
So 225 is the opposite, and 450 is
It's
adjacent.
next to, so it's the adjacent.
Yeah.
Okay, so the tangent of A equals 225 over 450. And so you're used to the A being given, like A is 30 degrees, but here it's not. Do you know how to undo tangent?
Reciprocal.
Okay, it's there's an inverse. There's a tangent, inverse.
That's what I was. I did not
Yeah,
think
it
but inverse.
yep. So your calculator has this on there. So the angle A is equal to the tan inverse of 225 over 450.
This is 225. 26 point.
Okay, so 26.6 degrees. Okay,
You
so
just
now what I was trying to show you here is that this airplane, we made this triangle where it goes that way and then it goes that way. So the angle here, we're trying to figure out this angle right here, and we figured out this angle right here. We're like, well, how does that help you? Well, if we draw a line parallel to this angle right here is 45 degrees.
Oh, because the top 90.
Yeah. And so the angle we just found is the one that's in here. So the course is 90. That's this 90 plus another 90 plus 45 plus A, which is 26.6. So it's all those added together.
And that's the bearing.
Yeah, 225 plus that, so 250, 251.6.
Oh. 26.6. And then okay. So that's just a little longer, a little longer way to do it.
All right, the next question is number 5, and this one's a little more clear, but again, there's triangles you have to draw that you're not comfortable drawing them. Okay. All right. So from the ground, Sandy observes an airplane coming toward him. Okay. So so I'm gonna assume that Sandy is right here. Okay. And he observes an airplane coming towards him. There's the airplane up there. Again, it's a right triangle. The angle of elevation changes from 25 to 65 degrees. So what is meant by that is Sandy is still there, but the plane's closer. It moved some distance. Okay. And the first time in the initial setting, 25 degrees. But then the plane got closer, and that's why it got steeper. Oops, 65 degrees. The plane's altitude is always 2,500 feet. It doesn't dip. Okay. How far does the plane travel? So we're trying to find this distance here.
Okay.
So if you know this length right here, which I'll call it, I don't know, I'll call it X. And if you know this length right here, D is equal to X minus Y.
Okay.
So the question or thing you should be thinking about is, could you draw this picture from on your own? Could you do this on your own?
I think so. This picture's a lot more clear than
Yeah. So what most students do is they redraw it they overlap the existing triangle, and you really want to separate them out.
Okay.
We can do a variation on this problem next if you'd like, but
you don't solve it? Or?
No, we are, but just to give you another shot at this. So
yeah. Okay.
Okay, so to find X, so again, I'm always going to ask you the same question because it's your ability to use these three trig functions relative to this angle right here, 25 degrees. What is 2,500 and what is X? And then as a result of that, which of those three trig functions are you going to use?
Okay, so 2500 is opposite and x is adjacent. So tangent.
So the tangent of 25 degrees equals the opposite, 2500 over x. This is different than one of the earlier ones because you have to get x now out of the bottom of the equation. To do that, you can cross multiply. So you get x tangent 25 equals 2500 times 1. Divide both sides by tangent 25. So x equals 2500 divided by tangent of 25 degrees. And that gives you a number. So we can get that now or we can get that later, but that's the first number. And that is going to be the larger of the two because that's the further scenario.
Okay.
Okay, so now in this picture, it's the same set of givens. You're given the opposite side.
Wait, so I should solve that for x, right? Though.
Yeah, we have to do it twice. I was going to wait, but yeah, you can
Oh,
do that right now if you want. It's a large number, but
5361.
okay. So in the second picture, the tangent of 65 is 2500 over y. So in this, we'll write this over here. So the tangent of 65 degrees equals 2500 over y. And it's the same steps to solve for it. See if you're comfortable getting down here to 2500 over tangent of 65.
Okay. Y. And these are both distances, correct?
They are, yes.
Okay. So that's 1. Oh, feet. Okay. For 4195.
Okay.
Okay, that one's pretty straightforward, not terrible.
Okay. Let me come up with the question here. So Billy is looking at I don't know, we'll call it, it's usually a mountain. And the angle of elevation is, I don't know, let's say 20 degrees. Let's make it 10 degrees. Susie is standing 200 feet closer, and the angle of elevation is, oh, I have a wrong number here. Sorry, it's 10 degrees, not 210 degrees. The angle of elevation is, let's go 35 degrees. 35 degrees, okay. All right, so first thing I want you to see if you can just draw this picture, this scenario. Then I'll give you the questions for this, if that's okay.
What's the height that they're both at?
The height is not given.
Oh, okay.
And there's a reason for that, because that's one of the things you solve for. But let's just see if you can draw the picture.
Angle of elevation is 10. $35. Okay, I think I got it.
Let me know when you've got a picture drawn.
I think I have. I think it's right.
Okay, so there's really two pictures you could draw, and they're both correct, but one is easier. So here's Billy, and he's looking at the top of a mountain. We don't know its height, and the angle of elevation is 10 degrees. Then Susie's right here. Okay, and this right here is 200 feet, and she's looking to the top of the mountain, and that's 35 degrees.
Okay, I separated them.
So the more practical one here is you first draw Susie, 35 degrees, H, and then I'm going to call this X.
Okay.
Now Billy is 10 degrees, still H. What is the distance though between him and the mountain?
200. X minus 200.
They're added together, 200 plus X.
Okay.
Okay. All right. Now, let's go to this first drawing. The tangent of 35 is H over X, opposite over adjacent. Do you see that?
Yeah.
The tangent of 10 degrees is H over 200 plus X. Opposite over adjacent. How many equations do you have? How many variables do you have?
2.
And how many variables?
2.
So can you solve this?
Yeah.
Yes. Now, do you think your instructor would give you something like this?
Maybe. So you would just move the X over.
So I would solve this for H. So H is equal to X tangent 35. And then come down here and use that in this equation. So I'm going to just rewrite it over. So tangent of 10 equals X tangent 35 over 200 plus X. Okay. And then there's just a lot of manipulation to solve this. I can work through this if you would like, but this is the path there.
Okay.
What's that?
I don't think you need to work.
Okay. Notice that if H is given, like if they say, oh, it's a 500-foot tall mountain, you can immediately find X.
Like that was like what they gave us in the last problem.
Yeah. Yeah. Okay. Should we look at number 2? That's sort of a conceptual problem on 4.8, or would you like to go in a different direction?
No, let's do that one. Yeah.
Okay. So it says decide in each scenario whether something is a simple, whether it's harmonic motion. And harmonic motion means that something gets back to the same position that it started in. Okay, so like maybe maybe a piston isn't as clear as something else. I'm sorry, this is a mass. So a mass oscillating up and down on the bottom of a spring. So the idea is you have a mass, you have a spring, and then you have a mass, and it goes up, and then it goes down, and then it comes back up again. So does it return to this position? Like at some point when it goes up and then goes down? Yes. Okay, so this is definite yes. Now, the question does say assume these things. Your instructor either has a background and sort of good science background, or they're trying to get across what would happen if there was friction is that this thing actually wouldn't go up and down forever. It would like if you've ever done this in your car, sometimes you'll push down on a car and it starts bouncing up and down a little bit, right? Maybe you've seen that.
Yeah.
Well, what happens eventually? It stops doing it. Well, that's because of friction.
Okay.
So what the instructor is trying to describe is this perfect system where there is no friction.
Okay.
I'm actually trying to think of some good examples, but where they're really like most things do have friction. I think that's why the instructor had this written here.
So what would the explanation would just be that it passes like that it once it while it's in this motion it'll like go to the same point or
Yeah, it always returns to the same point, but it never. So if we were to graph what happens here, it always returns back to the same point.
right? Okay.
Whereas if there was friction, it would slowly get to where it doesn't move at all. So this is with friction.
The same point. Okay.
All right, so let's look at the next question here. It says a piston, which is attached to a wheel that is slowing down. So maybe this isn't clear, but a piston is kind of just like a spring. It moves up and down.
Okay.
But if you're slowing down, that means that it's not moving up and down as much. It still isn't like these aren't clear. So like the piston moves up.
Uh-huh.
This is up, and then the piston moves down. So you might think, well, it's the same as the previous scenario, but the difference is that because the car or whatever it is slowing down, it will eventually, rather than taking these huge swings, it'll slow down to where it's not moving at all.
So that would be like the with friction on the last one, but it's not. It's
Yes,
not because it has friction. It's just because it's slowed down.
it's slowing down, and that is the equivalent of friction. Yeah,
Oh.
exactly.
Okay. So it's not harmonic motion then.
No. Very few things in nature are pure harmonics because if you studied physics, it's like things in motion tend to stay in motion. I mean, I don't know anything that stays in motion. I mean, most things are, you need to apply something to it to keep it going. Have you seen you've probably seen this thing where there's the three balls and then one at the end, and then you hit it, boom.
Yeah.
What happens to that one?
It goes.
It goes to the right.
Yeah.
Well, this is a pretty good one because this goes for a while, but eventually it slows down. So even that's not a perfect one. Do you have a grandfather clock in your home?
No, but I know
Okay,
what they
you
look
know what
like.
they are. So that's the example I give here. Every grandfather clock comes with a pendulum, and it swings left and it swings right, and you're all happy when you set yours up because you can hear the chime and everything like that. But every night you're supposed to rewind it because, and maybe a watch is a better example. Maybe your mom or dad have a watch that they've got mechanical movements inside that you have to rotate them or they stop working, and that's because they have to sort of rewind to get this amplitude back. But if it always has the same amplitude, if it always goes back to one position, right, left, right, left, right, left, that yes, this is a harmonic oscillator because it always gets back to the same position.
It always goes back to the center.
Or you could say it always comes back to the right or the left, like wherever it starts, it always gets back to.
Okay. Goes back to where it starts. Okay. Okay.
Okay, so where should we go from here?
looking. Oh, I had a question. This, I mean, it's not a conceptual or anything, but on where was it? 4.3, that first exercise, we started going through it a little, but
Yep.
I don't think we ever did the G8, F, G, H, or I.
Yeah, so there's actually several of these that we can talk through. Like it's not just where is tangent undefined. You can ask about cotangent as well. You can ask where. Okay, so tangent. We'll talk about tangent first. So tangent of theta is sine theta over cosine theta, and you know that you can't divide by 0.
Yes.
Can't divide by 0. So where's cosine equal to 0 on the unit circle? So if you have that unit circle handy, pull it up. If you don't remember your unit circle, just draw one. Cosine is the x coordinate. Where's the x coordinate 0? Well, it's there and there.
Right.
So what angle is that? Well, the common answer is it's 90 degrees. We want to use radian. So you asked that earlier, where to use that. And it's if theta equals pi over 2, or if you go all the way around, that's 270 degrees, or 3 pi over 2.
Oh, okay. So that's, I see. Okay.
Now, what if your instructor said, is tangent of theta defined or undefined at theta equals minus pi over 2? So do you understand that these are positive angles and that these are negative angles? And where is that? Where's negative pi over 2?
I don't know.
It's right there. So what is the x coordinate there?
0.
0. So the x coordinate is cosine.
So it's undefined.
So it is undefined. So notice, like, you have to be careful because this doesn't even say anything about like 0 to 2 pi, which is common. Sometimes they want you to go minus 2 pi to 2 pi. Like, you need to know that because, like, it's totally reasonable to ask that question.
So would negative 3 pi over 2,
Yes.
would that be the same place that 3 pi over 2 is now?
No, that's up here. That's negative 3 pi over 2. If you're going this direction.
Oh, if you're going, okay.
Okay, we're going to do I next.
Wait, so, sorry. For F, sorry, I'm just going backwards. What is that? Cosecant? Yeah, cosecant. So that's the same as sine, right?
That's right.
Okay. So it would be quadrant 3 and 4 for that one.
So all students take calculus, and that's here and here.
Okay.
And again, that's kind of like, well, what's the angle? Well, if you're going this way, if you're going positive, it's one set of answers. If you're going negative, it's another set of answers.
Okay. Okay. Thank you.
All right, now we're going to do I next because I is like G. These are kind of related. I'll just write that over here. I secant theta is equal to 1 over cosine theta. Where is cosine theta equal to 0? Well, at the same places as tangent, because tangent is sine over cosine. So it's pi over 2, 3 pi over 2. I'll throw the other ones in. Minus pi over 2, minus 3 pi over 2. These are the same.
But they want you to say the negatives too.
I don't know because it doesn't say.
Okay.
And I'm trying to prepare you for your instructor. That's
better safe than sorry.
Maybe difficult. Madison used a term called pity points, which I really liked. I don't like it, but I think it's funny, amusing. But it's the more you throw down, the better chance you have.
Okay.
All right, so let's look at cotangent of theta. We'll call this letter J. Cotangent of theta. Where is it undefined? Well, cotangent is many things. It is 1 over tangent of theta, which is not very useful, but it is cosine theta over sine theta. because tangent of theta
Oh, and
is,
you just flip them. Got it.
that's right. So it's not useful, very useful. So where is sine theta equal to 0? Well, again, that's asking where is the y coordinate on the unit circle? Where's the y value equal to 0? And that happens here and here. So at 0 degrees pi, that's if you're going this way. You could also say 2 pi. That'd be okay. What if you were going the other direction? Well, it's still 0, but if you go this way, that's minus pi. If you keep going, that's minus 2 pi. So any of those would be totally acceptable and reasonable.
So minus pi and minus 2 pi. Those would be there.
Or pi. Really, you probably want to cover the positive ones first, 0 and pi.
So theta, you would still do like theta equals.
Yeah,
right?
0 and pi, minus pi, minus 2 pi. It actually goes on forever. So, well, and I'm so the H and J are the same.
H and J.
Well, I made up J. J is cotangent.
Oh. Okay.
They're the same because it's the one that's missing. So, like for example, if your instructor could ask you a question like this, could say is cosecant of theta undefined at minus 17 pi? True or false?
Well, okay.
Well, I mean, so we'll leave it that way.
Cosecant is the same as sine. So.
Well, it's the same as cotangent. It's got the same undefined and defined.
Oh, because sine is on the bottom on
Yes.
cotangent.
Yes.
Okay.
This is equal to 1 over sine theta.
What do you do with this negative 17 pi?
You got to figure out where that is. So what I was trying to get you to see is like if you go positive on the unit circle, 0, this is 1 pi, 2 pi, I'm going around 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, right?
Oh, okay.
So notice wherever if it's n pi, you're here or here. Well, does that work for the other way? Well, 0 minus pi, minus 2 pi, minus 3 pi, minus 4 pi, and so on. So n pi gives you a point here or here. Is that undefined for cosecant? Is the x value 0 at either of these points? I'm sorry, the y value.
The y, yes, it's
Yes.
0.
So that is true.
Okay.
Okay. Now, what if? Now, let me give you another one. Is tangent of theta? Well, let me do it true false. Tangent of theta is defined at 47 pi over 2.
Pi. Oh, so that's the top or the bottom.
It's one of these positions, but it's a different function now. It's tangent. It's not.
Right. So that's sine over cosine. Yeah, sine over cosine. So cosine is the x coordinate, and that's 0, so it's undefined.
So the x coordinate here is 0. So because that's sine over cosine, cosine is yes. So this would be false.
Okay.
And so you could ask this for any of the trig functions, really. I mean, they're pretty straightforward true false things. So yeah.
Okay.
All right, so give me just a moment here. Why don't you? We got 5 minutes left. What else? Do you want to keep going on this topic, or do you want to choose a new one to look at?
No, I'm gonna look at this. Oh, so I just had a question on 4.21. Do they just want you to list like tangent equals sine over cosine, like that kind of thing? Or I don't understand what the question's asking.
What I don't like about this question is you're not sure what to put, but I think it's because they don't label any of the sides.
Yeah.
I would give the sides. Whoa, I have a little freeze up there. What I would do is label the sides. At a minimum, I would go like I would give them letters, like
And then
relative to, like, this is adjacent, this is opposite, and this is hypotenuse. That would be one way, and then it's let's do the better ones first. Like sine is O over A. I'm sorry, opposite over hypotenuse. Cosine is A over H.
okay, so they just
Now,
want you to write the okay.
now if you don't like that, let's give them numbers. 3, 4, 5, because those work. 3 squared, 4 squared equals 5 squared. Um,
Okay, so it would be 4 over 5 and 3 over 5.
mhm.
Okay, so all right. So what about the other ones?
Okay, so like a cosecant is the reciprocal of sine, so it would be H over O.
Okay.
Secant is the reciprocal of cosine, so it would be H over A.
H over A. Okay.
Tangent is opposite over adjacent.
And then cotangent is adjacent over opposite.
Yes.
Okay. Awesome. Okay.
Okay. So let's just do a real quick problem here related to this. So let's say I give you a triangle like this one, and I tell you that the secant of theta equals 17 over 15. What is A, what is B, and what is C?
Secant of theta. So secant is 1 over cosine.
Okay, so if
Then
that's true, you can rearrange this so that when you flip the left, you flip the right.
so 15 over 17. So
How do you find B?
Pythagorean theorem.
Yep, this one's actually Pythagorean triple. It's the second one. You should always try to remember it's the 8, 15, 17.
Isn't there one with 13, or am I just making that?
Oh yeah, it's the third one. Yeah. Although, like, me and this guy debate this all the time. He likes this one next, which
Oh,
I don't like
I
as
don't
much.
like that.
But that's it. Okay, so that takes us to the end of our lesson today. If you have your exam upcoming this week, I hope you do well on it. And
Thank
thanks
you.
again for scheduling. I'll send out the notes and screen recording here shortly.
Okay, thank you for your help.
You're welcome. Bye now.
Bye.